Hello everyone, welcome to another edition of Steve Does GIS. Here I'm just going to be showing you how to derive secondary variables of slope and aspect and hillshade from a terrain model. You can see I've already got the terrain model loaded, and all I simply do is go to the Arc toolbox and look down in the Spatial Analyst tools, click on the plus icon to open that up, and then go to Surface down at the bottom here. And in here you can see with various tools available. One is aspect, there's another one hillshade, and another one slope. Let's start with slope. I'm going to derive slope using this digital elevation model. So I'm just double clicking on slope. My input raster is my DEM. I've already got that open, so it should appear in the click down list. I will now direct it to where I'm working. This might look a little different on your machine, but I'm just making sure that it's going into my current workplace. I'm going to call that slope underscore 107. Whoops, 107.5. Don't know what happened there. Click save, and you can see in terms of output measurement, we have a couple of options. We can calculate degree, which is the inclination of the slope in degrees, or there's an alternative of percent rise, but we're going to stick with degrees. There's also another optional factor down here, which is the Z factor. So if our horizontal measurement was in meters and our vertical values in the terrain model were in feet, we could use this to manipulate the Z factor. But because both horizontal and vertical measurements here are both in meters, we needn't alter that. Now we just simply click on OK. You'll notice down at the bottom of the screen the blue scrolling slope, which is doing the calculation. And there you have it. It will put it into a series of categories. We can right click on properties and put that symbology as stretched. If we want to return the nice little red to green colour scale, we can do that. Flipped it round, so I should have remembered to apply the invert, which is there, and there we have it. So the green slopes are those with which are relatively flat, and the red those with a high slope. We can do the same for aspect. Just click on the aspect tool. Again, our input raster is not our slope, but our digital elevation model, of course. And again, just direct that to where we want to put it. So again, I'm going to call that aspect underscore 107.5. And there we have it. Just click on OK. And that's the aspect. The bright colours there, you'll note in the layers menu, are split up, categorized into the cardinal points on the compass. So we've got north, northeast, east, southeast, south, southwest, west, northwest and north. There's the values of -1 are those slopes which have no aspect, so these are flat slopes. Looking at the map, you'll see there are one or two aberrations or elements in the data which are artifacts due to lack of information in these areas, and this is down to the interpolation of the DEM in these very flat areas. You can see in the high relief areas it's doing a much better job of distinguishing which slopes are facing in which direction, hence the better interpolation in this lower left corner, for example. Final thing I'm going to calculate now is hillshade. So again, just input my digital elevation model raster, tell it that I'm going to call this hillsh underscore 107.5. The two inputs here, default azimuth. Now azimuth, if we click on there, we'll see that this is the angle of the light source relative to north, and so this is putting the sun up in the upper left-hand quadrant of the study area. It's an unusual place to put it in the northern hemisphere because you very rarely see the sun up there, but it does make the visualization a lot better, as we'll see in a minute. Altitude is the angle of the sun above the horizon, We can also click this checkbox here to model shadows. So if there are any shadows in the area, it will model those. Again, Z factor we can leave as 1. Okay, and there we have an image of the hillshade output as a grayscale. It's normal to display this as grayscale over the top of our digital elevation model. And the human eye is really very good at picking out terrain surfaces from this kind of an image, which, coming back to the azimuth, is why we quite often position the sun in the top left-hand quadrant. We could make this transparent, so I can click on Properties, Display, and let's add that at 50% transparency over the top of our other layers. Doesn't really look much on the aspect, but it really does make the slope and the terrain models stand out very nicely. Just as an experiment, let's just repeat the hillshade with the sun in a different quadrant of the sky, and we'll see that it can make quite a difference. So I'm going to call this shade 1, just to distinguish it. And I'm going to change that azimuth. Let's put it down somewhere in the lower right quadrant. So 90 plus 45, 135 degrees. I'll model my shadows again. Right, that looks really different. I don't know about you, but to my eyes it looks like the mountains are now canyons, and this the valley down the bottom here, the player, looked like a plateau. And again, we can just put that as a transparent overlay over the top of our terrain model, just to make that even more so. So yeah, there is a method in the madness of the default of 315 degrees azimuth, because that looks like a lot better visualization. Okay, simple as that. I'll sign off now.